This video is for Math 70, and this topic, a lot of people call this solving literal equations. What these are equations that have more than one variable in them, and the idea is that we want to isolate one of those variables. This happens a lot in the sciences where you get formulas that have a bunch of different variables in them, and if you isolate one of those variables, then when you get values for the other ones, you can just plug them in and get a value for the variable that you're interested in. So that way you solve once and then just calculate as many times as you need an answer for, rather than plugging everything in and solving it every time you need it. So let's see here. So I'll start off with these even problems here. Problem 2. C equals 2 pi r, and we want to solve for r in this one. Okay, so this works just like the equations that we've been talking about for the past couple weeks, just the same way that they work, right? What's happening between all of this over here on the right hand side with the r is multiplication. So to undo that, we want to divide through by the 2 pi, and do that on both sides, and so then we get the r by itself will be equal to c over 2 pi. Alright, problem 4. We've got s equals vt plus 16t squared, and we want to solve for v. Okay. So just like we do when we're solving for just a single variable, we first want to isolate the piece that has that variable. So here it is. This is where the v is. So we need to isolate this first. So let's move the 16t squared to the other side. Then we'll just have vt here, s minus 16t squared on the other side. Now, to get the v by itself, we want to divide on both sides by t. Over here, notice how we have to divide the whole side by t. Okay? Over here, there's just a single term, so we just have to divide that by t. That'll get the v by itself, and over here, you'll have s minus 16t squared divided by t, and that's our answer. Okay, let's see here. Problem 6, what do we have? S equals 1/2 gt squared, and we want to solve for the g. Okay, well, same thing here. All that's happening here, well, here we've got multiplication. Here, this is more like division. You can technically divide on both sides by 1/2. But that's going to get you into a situation where you've got a fraction inside a fraction, and that's something we like to avoid in mathematics. In fact, it's considered to be not simplest form, so that's why we want to avoid it. So really what we want to do in this scenario is to multiply on both sides by 2. That'll cancel out that 1/2, and we'll have gt squared equals 2s, and then we can just divide on both sides by t squared. And that'll give us g equals 2s over t squared, and there we go. Okay. Let's see here. Problem 8. What do we have? dy plus c equals h plus 3. Okay, and, what are we solving for here? We're solving for y. Okay, so first, identify the term that has the y in it. Here it is right here. So that means we need to move this c over to the other side. h plus 3 minus c. Okay, now the d is getting multiplied by the y, so we need to divide on both sides by d. And again, notice how I divide all of these pieces by d. And so this is h plus 3 minus c, all divided by d. And you can even split those up in the same way that you can distribute multiplication across addition, right? If you had 3 times x plus y, that's 3x plus 3y. If you had x plus y over 3, that's x over 3 plus y over 3. So if you really wanted to, you could split these all up, and sometimes that is helpful to do. Okay, but in this situation, I think it's much simpler just to divide the whole thing by d and leave it that way. All right, number 10. Let's see what we've got here. Number 10 is very much like number 8. Well, let's go ahead and take a look at it. Let's see, 2n minus b equals a plus b. Well, in this one, though, I guess the one difference is that the n, right, we're solving for n. Let me double check that. Yeah. So we need to get rid of this b, move it to the other side. So I guess this is a little bit different because when we do that, we've got a like term to add it to. So we'll get a plus 2b over there. And then when we divide on both sides by 2 to get the n by itself, we can get a plus 2b over 2. And what I was saying about this is also true here. You could call this a over 2 plus 2b over 2, and then those would cancel. And you would have a over 2 plus b. But like I said, a lot of times it's just easier to leave it like that. Okay. Problem 12. M equals x plus y over 2. And we want to solve for y. So again, remember in that formula, which one was that? I think that was problem 6. We had that 1/2 in the formula, and so we multiplied on both sides to cancel it out. And that's, again, what we want to do here. Multiply on both sides by 2. So we'll get x plus y equals 2m. And then to get the y by itself, just subtract x on both sides. And there it is. Y equals 2m minus x. Okay, I've got a couple more problems to look at. Let's see, problem 14. Let's see, v squared equals u squared plus 2as, and we want to solve for the s. Okay, so first thing is we want to get the term that has the variable we're interested in by itself. So that means this is going to move to the other side. So then we'll have 2as equals v squared minus u squared. Now, this is all multiplication here, right? Everything's getting multiplied. So we can divide by everything that's not the variable that we're interested in. 2a. So s is going to be v squared minus u squared over 2a. All right, one more, problem 16. Problem 16. T is equal to m times g minus b, and we want to solve for g. Well, there's a couple different ways that we can approach this. One thing we can't do is to try to add b in this situation. Because this multiplication, remember the order of operations, you've got to do this multiplication if you want to get at anything that's inside those parentheses. So that's one approach to doing this, is to multiply the m into the parentheses, and then isolate the term that has the g. So mg equals t plus mb. And then divide on both sides by m. And so there we would get g is t plus mb divided by m. The other thing you can do here is because that m, Well, I don't really need to use that pen because sometimes I do that for things that are wrong. So let's keep the purple because there's nothing wrong with this. Okay, so I mentioned there's multiplication happening between the m and the parentheses. We can divide on both sides by m. We could divide on both sides by what's inside the parentheses too, but that wouldn't really get us anywhere. Divide through by m. Now we've got t over m equals g minus b. And then all we have to do is add b on both sides. And notice how I was talking about how you can distribute division, right? This is t over m plus mb over m. Those cancel out. And so if you do that, you can see how these two answers are actually the same answer. And neither one is wrong or better than the other. It depends on the situation that you need this for. Okay? So whether you call it this or whether you call it this, it depends on what you need to do with it. Okay, so I think that's it for this assignment. Let's see. So we've got one more set of topics before we get ready for the midterm. We're going to talk about some graphing next week. And as always, if you have any questions about these, please let me know. Thank you.